A very good morning to Doctor. We are from Group 2. Today we are going to explain about our EC project report. So they are my group members. So without any further ado, we start our presentation from the circuit 1. So now I will show you how the circuit 1 to be developed by using Multisim software. So there are 5 steps to be done. So step 1, we start our circuit by arranging 2 voltage source of active volt. So at the upper and the bottom of the circuit. So next, we create 3 resistor of 20 ohm and also 3 resistor of 30 ohm. And then we assign them as R1, R2, R3, R4, R5, and R6. So step 3, we connect then in with the connecting wires. Okay. Step 4, after completing the connection, we put a ground at the bottom of the circuit in order to ensure the simulation can operate successfully. So step 5, which is the last step, we add the voltmeter and the ammeter into the circuit in order to determine the value for V0 and I0. So after all are completed, we start our we can start the simulation. Okay, now I will show you how circuit 1 can be solved by using manual calculation. So the first step, okay, we need to start the calculation by assigning the mesh current. So I1, I2, and I3 in clockwise direction. So since I0 is in the same direction with I3, so we can let that I0 is equal to I3. Next, we need to apply KVL into this meshes to get 3 main function here. After getting 3 main function, we need to apply Cramer's rule. Okay, this is Cramer's rule to find out the value for I1, I2, and I3. Okay, since the value of I0 is equal to I3, so its value can be determined easily. So how about the V0? V0, we need to use the Ohm's law to calculate to be calculated because the formula is here. V0 equal to 30 I0. So I0, so we just need to substitute the value for I0 into the formula so we can get the final answer. So move on to the circuit 2 here. Same scope, we have only 5 steps to be done. Step 1, we start our circuit by arranging independent current source of 6 ampere, independent current voltage source of 30 volt, and a current control current source here. Okay, step 2, we need to create 3 resistors, 10 ohm, 20 ohm, and 40 ohm. After that, we assign them as R1, okay, R2, and R3. Okay, step 3, we'll connect all the elements with the connecting wires. Step 4, after completing the connection, we also need to put a ground at the bottom, okay, in order to make the simulation can be operated successfully. Step 5, which is the last step, we add the ammeter here and voltmeter into the circuit, okay, to find out the value for V0 and I0. But at here, we need to add a refer 1 at here for V0 because it can help us to determine the value for V0 easily. So after all are completed, we can start our simulation. So turn to the manual calculation. Okay, in circuit 2, we select point A as reference node. Then we need to assign all the branch current, which is I0 here, I1, I2, and I3, okay, to each node. Then we apply KCL to those nodes to get these 2 main functions. Okay, in the equation, we also use Ohm's law to express the branch current in terms of the not voltage. So in this case, we use VA and VB. Okay. After getting two main equation, we solve it by using simultaneous equation. Okay, to get the value for VA and VB. Then we can calculate the value for V0 by using this formula. V0 equal to VAV. Then VAB will be equal to VA minus VB. So the last final answer will be active volt only. Then the I0 can be also determined by using Ohm's law again. So at the end, the I0 will be comes up with 1.8 ampere. So in conclusion, we found that in circuit 1 and circuit 2, both methods can be applied and both methods can get the same answer. So there is not any error happening in these two cases. That's all. Thank you.